All right, so um, step one, identify the vectors that have been given, right? So I think we've been given a wind vector for sure. And the wind vector is (20 meters per second) at an angle of 30 degrees south of west. That's the wind's vector. We only know that the plane can travel at 100 meters per second. We don't know anything else about the plane, except that we know that when I add the plane and the wind together, my answer has to be due north, which means it can't have any x component in the result. Does everybody understand that part? Because I had some real trouble with that in the 7th period yesterday. Now, I'm going to draw the wind first, because I kind of think it's a good place to start. And I'm going to do a few other things that are part of our series of steps, but perhaps out of order. We need a common coordinate system that we're going to use for all of the objects. And so I'm going to use a coordinate system that has north, south, east, and west delineated in it. So something like that. But I will label this north and positive, and this one as east and positive, and this one as south and negative, and this one as west and negative. That all okay? So this is my common coordinate system that I will use for both. So since I'm using it for both, I will duplicate it real quick and make one for the plane and one for the wind. So let's do the wind first, because it's relatively straightforward. It says 20 meters per second, 30 degrees south of west. So I will start at the west and turn towards the south. And turn towards the south 30 degrees. That all good? Now, at the end, the very end of the problem, my plane needs to go that way. Does everybody understand that part? So if the wind is blowing to the left, I'm pretty sure that my plane is going to have to fly upwards and to the right. Upwards enough to the north and to the east. But it has to fly north fast enough to overcome the fact that the wind is in its face and blowing a little bit to the south. And it has to fly east enough to counteract the wind blowing it to the west. Does that all make sense? So do you see why I've kind of drawn the plane in this direction? Because if you don't understand that part, you can't do the rest. Okay. So this, I don't know that particular angle. I'm going to use a placeholder for it. I do know that the airspeed of the plane is 100 meters per second, and the wind speed of the plane was 20 meters per second. So now I think I've done what I can to identify the vectors that were given. I don't know as much about the plane as I would like, but I know several things about it that I can use. So I think this starts my problem. Now after this, I'm supposed to break up my vectors into their components. And that's just the trig portion of this. But I can't really break the plane up into components because I don't know the angle. So I'll start with the wind because I know everything about the wind. And I'm going to say that there's a component this way and a component this way. Does that make sense? Looking just at this, and I hate drilling down to this minutia, and maybe this class doesn't need it, but my other two do. I had to label the sides opposite and adjacent. That all good, guys? And then sine 30 degrees equals opposite over hypotenuse. Cosine 30 degrees equals adjacent over hypotenuse. So my opposite side is 20 sine 30, which is 10. My adjacent side is 20 cosine 30, which is, see, 0.866, so 17.2, 0.3. So 17.3 and 10. Everybody good there? So for the wind, I'm going to say negative 17.3 in the x hat direction, because this is in the x direction, and negative 10 in the y hat direction, because this is in the y direction. And both of those point in the negative directions. Any questions about those choices? All right, so I'm going to get expressions for the plane. I won't get numbers for the plane because I don't have the angle. But let's look at the plane. I think I'll have a component in this direction to the north. I think I'll have a component in this direction to the east. And I'm going to label this my opposite side and my adjacent side. Are we all good with that? So now I'm thinking sine of my unknown angle equals opposite over 100. And cosine of my unknown angle equals adjacent over 100. So my opposite side is 100 sine theta, and my adjacent side is 100 cosine theta. I can't write them any more than that. That's as much as I can do. So I'll write out my sentence that tells me the components. It looks like I will have positive 100 sine theta in the x direction plus 100 cosine theta in the y direction. All right. We're going to add like components together. That part's still not changing. Now, I'm going to do this a little different than I talked about it yesterday, just for demonstrative purposes. Look at the white arrow. The white arrow represents what the plane is going to do when it lands. It has to go just due north. So I know that whatever the answer is, it's going to be 0 x hat, right? No component in the x direction plus something y hat. That's got to be the answer. I don't know what either of those. I know the one has to be 0. And the other one can be whatever it is. I don't care. So when I see these two vectors, and note that they're going to be added together, I know my answer has to have 0 here. Everybody all follow along with why that has to be true, because that's the critical part here. So that means I'll have 100 sine theta minus 17.3 has to equal 0. Now I also know I'm going to have 100 cosine theta minus 10 is going to be the portion of the vector in the y hat direction. I'm still adding them down. I can't get an answer here because I don't know theta. I can get an answer for theta here, though. So that's what we're going to do. We're going to get an answer for theta. So to get an answer for theta, I'm going to add 17.3 to both sides. I'm going to divide by 100. And now I'll take the inverse sine. Now I need an answer here, so this is where the calculator comes in. I get 9.96. I'm just going to write 10 degrees. Now, I'm going to finish this part off too, where I have 100 cosine 10 degrees minus 10 is all in the y direction. And that gives me 88 y hat. Now, the plane, that's its ground speed. We forced the direction of the plane to be due north, which is why it's got 0 in the x direction. That resulted in a y component that is 88 meters per second in the y direction. In fact, the plane at the end of the day is going 88 meters per second due north. It needed to be due north. It's the only way for it to land on the runway. So if it's traveling due north. This 10 degrees refers to the original vector of the plane. Way over here, 10 degrees east of north. That's the direction the plane had to go in order for it to line up with the runway. Does that make sense? Did that help solve what your problem was?
So just to clarify.
So if you had decided to make the other one theta, you would have had to draw your triangle this way, correct? That would have made this the adjacent angle and this the opposite, the adjacent side and this the opposite side. That would have changed these two trig functions and reversed them. But it also would have given you the complementary angle. Meaning you would have worked the whole problem out. It'll come out exactly the same, except you would have gotten 80 degrees for your answer and not 10 degrees. Do you want to see what would happen? Because it would only take a minute. So the only change would be that when we set this up, let me erase the stuff we don't need. So it looks like this now. I would go, well, sine of theta is opposite over 100, and that seems to be the one that's in the y direction. And cosine of theta is adjacent over 100, and that seems to be the one in the x direction. So the adjacent one will be 100 cosine theta, and the opposite one will be 100 sine theta. All still good until we come down here where these would be reversed. Where this one would be the one that's cosine and this is the one that's sine. Right? So get rid of all this, we'll start fresh. So we still do all the same things, except this time when we add up the x's, we get 100 cosine theta minus 17.3 equals 0. So 100 cos theta equals 17.3. Cos theta is 0.173. And when I find theta by doing the inverse cosine, I'll get 80 degrees. Now, I'm still going to have 100 sine 80 degrees minus 10 is going to be my component in the y direction. Just to prove that it all works out, when I hit sine times 100 minus 10, I still get 88 meters per second in the y direction. Okay? So when I come back up here and say 80 degrees, that's still a right answer. But this 80 degrees is north of east, not east of north. Do you see? Because we're measuring this relative to going east and then turning towards the north 80 degrees. Both of these are correct answers. They're two ways of saying the same angle. Does that make sense?
Okay.
So it's just fine. It works out just fine.
You can do either one.
Mm-hmm. You can choose what you want to how you want to list your angle. So in the problem, I say the wind is specifically 30 degrees south of west. But when it comes to this one, you can specify where you want that to be. In fact, in all of the other questions you had, you could have specified where you wanted your resultant to be measured from. In any one of those, you could have decided whether you did it from the vertical line or the horizontal line, and it would have been just fine.